So you cannot have this element between hydrogen and helium. And in fact, any two consecutive elements of the modern periodic table, you cannot have any element coming in between these two, because they are just some x atomic number and x plus 1. So how you can't put an x point, something like that. Then we come to this modern periodic table. Most of the questions are really from modern periodic table, because you have better questions rather than just theoretical questions from the modern periodic table. They ask you about trends, and they just don't ask you about the trends directly. They will say that there is a group, suppose group 16 and group 17, and then they will say that this is A, this is B, which is lying below A, and then this is C over here. So first of all, they can ask you regarding the trends, which one are metals and which one are non-metals. So either you can do one thing, is that you can just identify the elements. Just because group 17, if you just know, I mean, you don't have to really know this, but if you just know, it's better. Group 17, the first element is fluorine. Group 17 halogen group, first element is fluorine. And group 16, the first element was oxygen. So this would be sulfur. And this fluorine, chlorine, and then this would be bromine. So what do you think? All these are non-metals? Yes, of course, all are non-metals. And since they lie in group 16 and 17, they are much towards the right of the periodic table. And towards the right of the periodic table, they become non-metals. In the middle, they are in the transition phase. Towards the left, they are purely metal. And towards the right, they totally become non-metals. In fact, fluorine is the most non-metallic. Metallic, what do you say, element. So, if they ask you what if they are metals or non-metals, A, B, C, all three are non-metals. Then they will go to the size. Arrange them in increasing order of size. Now we have seen that size decreases along the period because the number of electrons increases, attraction increases, it attracts more and the size becomes smaller. So obviously A and C, they would be smaller than B. So you can just write like A and C are lesser in size compared to B. And then as you go down the group, the number of shells increase, so the size automatically will increase. So C will have a bigger size than A. So A will have the least size, and we know fluorine is very small, so it's just proven. A has the least size, then we have C, and then we have B. So this is the increasing order of their size. Then they might ask you the ion formed. They might ask you many questions, like what is its valency and what is its electronic configuration and stuff. I'm just giving you some examples. Like if you know the trends, then you can answer any question from any group, from any element. So just an example, what is the ion form? How do you go about the question? So what do you see in ion formation? What is the ion form? In the ion formation, first of all, you write the electronic configuration, find the valency and stuff. So we can say that group 17, if you remember, had a valency of -1. Because all this fluorine and bromine, if you use your common sense, they'll all form F minus, Cl minus, Br minus and stuff. So they will have a valency of -1. So they will form an ion as F minus. So you won't write F minus in the exam because you are not supposed to write the element. So you will write it's A minus. The ion formed by A is A minus. The ion formed by C, since it is in the same group, again it would be C minus. But the number of shells would be different in A and C. And B is in group 16. So it's just one group before 17. So it will form B2 minus. So the ions formed would be A minus, C minus and B2 minus. And then they might ask you what is the valency and stuff. Just need to examine the group. Since this is in group 17, it has a valency of -1. Or you can write just 1. This has a valency of 2. It will accept 2 electrons. These will accept 1 electron. So they ask you these type of questions. I mean, they give you just one set of compounds and then they'll ask you 5 or 6 questions for 5 marks or so. Then they'll ask you valency calculation, which is not very difficult. Valency calculation, I mean, it's just writing if A they'll give you, not A, X. X is in group, suppose say 14. So what is its valency? So if it is in group 14, then you see, if you just apply the formula or if you just apply common sense, you'll see group 1 has 1 electron in its outermost shell, group 2 has 2, then group 13, because since we are limited only till the upper part of the periodic table, which has no groups, I mean these transition elements, so then group 13 will have 3 electrons because we are jumping 10 groups. Then group 14 will again have 4 electrons, not 14 electrons, it's 4 electrons.